ಕುಲಕರ್ಣಿ ಅವರೇ, ಈಗ ಕ್ಲಾಸಸ್ ಮುಗೀತು. ಕ್ಲಾಸಸ್ ಈಗಲೇ ಮುಗಿದಿದೆ. 3:30ಗೆ ಒಂದು 3-4 ನಿಮಿಷ ಲೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಟ್ರಾನ್ಸಿಷನ್, the students will come out and then move into the hall.
Okay.
Then
ಯಾವ್ದು ಕೆಲಸ ಮಾಡಿದ್ದು? ಏನ್ ಕೆಲಸ ಮಾಡಿದ್ದು? ರಾಧಾಗೆ ಅಯ್ಯೋ ಅದು ಕಳಿಸ್ತಾ ಇರೋದು
कन्नड़ा सीएन रावत कर रहे भाई, कन्नड़ा बोल रहा है। हाँ कन्नड़ा तो कन्नड़ा का ही है। क्या बोल रहा है समझ में नहीं, आपको समझ में आ रहा है? नहीं आ रहा है क्योंकि उनका
ಯಾರು ಕೆಲಸ ಮಾಡುದು
ಗೊತ್ತಿಲ್ಲ. ಯಾರ್ಯಾರೋ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ, ಯಾರ್ಯಾರೋ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ ಎಂದೆ. ಅಲ್ಲಿ ನಾವು ಮಾತಾಡಿದ್ದು ನೋವಿಯರ್ ಅಂಡ್ ಕ್ಯಾಮ್ರಾಸ್, ನಾವು ಮಾತಾಡಿದ್ದು ಕೇಳತ್ತು ಅವ್ರಿಗೆ.
ಮನೆ ನಿಮ್ಮತಿ ಮದುವೆ ಆಗಿದ್ದೆ.
ನಂಗೆ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ರಾಮ್ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೀರ.
ಮದುವೆ ಆಗಿಲ್ಲ
ಯಾರಿಗೆ?
ಮತಿ
ದಿಮಹಿಗ ನಂಗೆ ಗೊತ್ತಿಲ್ಲಪ್ಪ. ಐ ಡೋಂಟ್ ನೋ ಹರ್ ಪರ್ಸನಲ್ ಲೈಫ್. ತುಂಬ ಚೆನ್ನಾಗಿ ಹಾಡು ಹೇಳ್ತಾಳೆ.
It's okay, Joy. We live with it, yeah. Sir, I'm told that there is a live streaming arranged in the physics department. So I was hoping that all the physics students as well as the faculty join us. But apparently in the seminar hall, there is a live streaming of today's lecture. So they're all stay put there. I think we can get started regardless. Yeah, Ajay.
A very good afternoon to everyone here. Bharata Ratna Professor CNR Rao, Srimati Indumati Rao, Director, IISER Thiruvananthapuram, Professor Jain Murthy, senior professors and colleagues who have joined online, faculty colleagues and students from IISER Trivandrum. On behalf of the School of Chemistry, IISER Trivandrum, I warmly welcome you to Professor M.V. George Memorial Endowment Lecture to be delivered by Professor K. George Thomas, who is Professor and J.C. Bose National Fellow at IISER Trivandrum. This Memorial Endowment Lecture has been graciously instituted by Bharata Ratna Professor C.N.R. Rao and Srimati Indumati Rao in fond remembrance of their enduring friendship and the contributions of Professor M.V. George to chemical sciences. I now request Professor Jain Murthy to make opening remarks by describing the background of this Memorial Endowment Lecture instituted by Bharat Ratna Professor C.N.R. Rao and Srimati Indumati Rao, and also to introduce today's speaker, Professor K. George Thomas. Sir.
I don't quite know really what to say. I'm really delighted and immensely happy to see Professor Bharataratna, Professor C.N.R. Rao, and Madam Indumati Rao gracing today's event. I don't think that I have to talk about Professor Rao. Before I do that, let me give for the younger generation, for their benefit of doubt, a little bit about Professor Rao and Madam Indumati Rao. Before I do that, I would like to kind of extend a warm welcome to all of you, colleagues, staff members, students, and visitors from outside. As I'm sure everyone in science in this country, I cannot think of anybody not having heard of Professor Rao Bharataratna. Like you, when I was a student, he was a big stature, as an icon for science, for generations, I would say, and an inspiration for scientists for decades. He has been an institution builder. And if you really want to think about somebody with passion for science, I think no other name should feature other than Professor C.N.R. Rao. If I am to speak of his accomplishments, they're unthinkable. Just before I came over here to the auditorium, I just basically Googled Professor Rao and looked at how active he is. Singularly exceptional, I would say, with well over 1.25 lakh citations. Forget about ordinary mortals like us, don't feature anywhere, with a H index of 165 plus. That's an unimaginable number. Right? Infectious. I've seen as I grew up as a student what Professor Rao is in terms of the energy. Even today, you find several publications coming from his guidance. I think, sir, we are truly privileged and blessed to have you here grace the event. In fact, we are most happy to see you virtually. I think I should talk about the genesis of the endowment lecture that we have today. I moved from Kanpur to here to head this institution in 2019. It was in the month of April. And it turned out that he was here sometime during August as part of a conference and in Trivandrum.
Murthy, there is some crosstalk. Maybe you
Yeah, that's why
don't
I'm
have
pausing a
to-
bit to just to tell them to. Can you mute all virtual speakers? Yeah, mute virtually everybody. Yeah. Now is it okay now, Kulkarni Avare?
Yes, it's fine.
So it was in the month of July, August. He was here as part of one of the conferences organized by Professor Josh Thomas. And again, he needed to be here in the month of December in connection with passing away of Professor M.V. George. At that time, we were fortunate to have Professor Rao here on our campus. I think it's very prudent that I recollect the moments that we spent, the days that we spent, we had the opportunity to spend with Professor Rao and Indumati Rao. I think I want to tell the student community, Professor Rao is 90 plus today. About 5 years back, I'm talking about 84, 85. He gave a standing lecture for well over 1 hour in physics seminar hall. 1 hour. Truly inspirational it was. And that's what he has been known for decades. At that time, and being here, he and Madam Indumati Rao wanted to institute an endowment in fond memory of his longtime friend and to symbolize the friendship that endured for decades. So let me kind of give you a little brief about that. And we were fortunate. He expressed that he's most happy to have that instituted in our country, in our institution. In fact, sir, we are really grateful that this is the subsequently we had 20, 21, 22. This is the 5th one that we are basically having in the name of Professor M.V. George Memorial Lecture today. So let me go through a little bit about this long bond between Professor Rao and M.V. George, who shared a strong bond of friendship and a common vision to see our country become an international leader in the field of scientific education research. Together, they established several activities to promote science and research in this part of country. CSIR NIST, where Professor M.V. George was pursuing his science as an honorary professor. With this, basically, CSIR NIST became a leading center for research in chemistry and materials. It was possible through the support and encouragement that they provided. They also established the foundation for capacity building in science. I think for the students that come from Kerala probably would have heard about and would know very well about FCBS. This was meant to popularize science among the youth and to attract them to science. Through its annual meetings, seminars, and workshops targeting students and teachers, FCBS has had a significant role in promoting a number of bright young students of Kerala to pursue their careers in science. Many young beneficiaries of this program are renowned scientists themselves today. With Professor Rao, when Professor Rao convinced the government of India to establish several IISERs in the country, Professor George could convince Professor Rao in turn to get one to Kerala, and which is how we have our IISER in Trivandrum with the blessings of Professor C.N.R. Rao. So from the inception, and it is with the ardent support of both for IISER TVM is really well recognized. Professor Rao continues to support IISER Thiruvananthapuram in many ways. So today's lecture is in memory of Professor M.V. George. Let me give a brief rundown of Professor M.V. George, a renowned organic chemist. He holds a unique place in the growth of photochemistry research in India. He was born in 1928 in Kollam, near Trivandrum. He obtained his bachelor's and MSc degrees from Union Christian College in Kerala, Alvai, and PhD in organic chemistry from St. John's Medical College, Agra. Then he did his postdoctoral research with some of the most renowned organic chemists of the time, namely George F. Wright, Henry Gilman, Melvin Newman, Derek Burton, the Nobel laureate, and Rolf Huisgen, who's well known. He then returned to India to be appointed at the Department of Chemistry of IIT Kanpur in 1963, where he continued his journey as a scientist, eminent scientist in the country for about 25 years, and superannuated in 1998. Subsequently, he chose to come back to Kerala and continue his science at NIST, Trivandrum. So, working in the area of photochemistry, Professor George published more than 200 landmark research publications in various international journals of high repute and guided many PhD students and postdocs. After his superannuation from IIT Kanpur in 1980, as I said, he came to NIST, and the photochemistry research unit that he set up today is really well known in the country, and which is the place that today's speaker basically began his career at NIST Trivandrum. So that said, I think, through generous support that Professor Rao basically extended certain amount, which was basically which is kept as in the bank, and the interest incurred upon that is basically used for conducting the lecture today in the memory of Professor M.V. George. And I must say that we are honored. In fact, IISER Thiruvananthapuram is should be really grateful that we have our own man, a local hero, being chosen to receive this particular award, Professor George Thomas. I think I should introduce my longtime friend and colleague, and we have been part of several conferences together for decades. In fact, we toured together to Taiwan and France and several places, even in Singapore, even before I came here. So we know each other professionally for a long time. So George Thomas is a local hero, as I said, pursued his bachelor's and master's degree in Trivandrum. Not, I think, in different place, is it? Bachelor's and matter around, but then PhD in Trivandrum in Kerala University, and subsequently joined Professor M.V. George and the photochemistry group in NIST in 1993 or 1994, and continued there until 2010. Right. In 2008, he was extended an invitation from IISER Thiruvananthapuram, which was newly established that year by Professor Jemmis, the founding director, to join our institution as the faculty member. But then he came and joined our institution in 2010. So,
So Murthy, not audible. I see your connection muted.
unmute. Can you hear now?
Yes. Now I can. Yeah.
So he's been a passionate teacher and a scientist who trains his students with a lot of passion. I see this every day from the morning till night, and sitting with the students and transferring the wisdom that he has. He has guided well over about 29 PhD students, published very, very impactful publications. As of course, for his contributions, he has been recognized with several awards, the most notable being the Shanti Swarup Bhatnagar Prize in 2006. And he has been a J.C. Bose National Fellow for 10 years, and he has been an elected fellow of the most notable academies of India. And of course, his contributions extend beyond the home institution and the country. He served as basically the president of the Asian and Oceanian Photochemistry Association, APA, from 2009 to 2021. And also he was on the editorial advisory board of the Journal of Physical Chemistry, published by the ACS for 3 years from 2012 to 2015. Astounding credentials, most deserving. And with that introduction to today's speaker, who is going to give the Professor M.B. George Memorial Lecture. May I now invite Professor George Thomas to deliver today's lecture. Thank you.
There is the same problem.
Bharatratna Professor C.N.R. Rao, Madam Indimit Rao, Director Professor Jayan Murthy, Professor Kulkarni, and those who are online, my colleagues here, senior colleagues here, students. It's a great privilege for me to be here today. And before going into the formal thing, let me thank Professor Jayan Murthy for introducing me and Professor Rao for selecting me for this year's Professor M.V. George Memorial Endowment Lecture. I've been associated with Professor Rao and Madam Indumati Rao for the last several years. And I will talk about that in a couple of minutes. Before that, again, I profusely thank Professor Rao for this opportunity and Professor Jayan Murthy for arranging this and Dr. Ajay Venugopal for organizing the event. So my association with Professor Rao starts almost same time I joined Professor George. So I want to talk to you about the lifelong the friendship of Professor Rao and Professor George that requires effort, deep understanding of each other, mutual respect, and more importantly, trust. I could find in these qualities in them, and this is a notable quality for the younger generation. And I feel that this is something we should follow. This is a photograph from IIT Kanpur, which I got from some of the senior colleagues. You can see Professor Rao and Professor George walking together. And I believe that these photos in 1960s. And I have another photo in the other side. Yeah, this is the photograph in 1990, if I remember correctly. And you can see the changes in the human beings. As you can see, Professor George was thin, and you can see Professor Rao is more or less the same way, and Professor George is become different, like in aspect ratio is slightly different. And you can see about a few years back, in 2018, this photograph was taken. And you can see the changes from 1960s to 1990s to 2018, about gap of 30 years, you could see that transformation, and they remained as friends. I looked at it, these are my personal notes. Both of them had a deep sense of belongingness throughout the journey. They celebrated each other's success and stood together through challenges. I will come through this one. In a minute, I will show you. This is the Madam Indumati Rao's association has to be highlighted here. This is her. This is a photograph taken in Munnar, if I remember correctly, when we had a JNC conference at Munnar. Professor Kulkarni and myself were organizing this conference. And you can see Professor Rao, Professor George, Madam Indumati Rao, and our former director, Dr. Vijayan Nair for NIST. Professor Rao, this is a photograph I have myself collected. You can see here Professor George and Professor Rao. Professor George is gifting Saraswati, a deity of Saraswati to Professor Rao, and you will see how happy he is, and they are together here with the photograph. So reverse, you can see the reverse. Professor Rao also always have an appreciation for Professor George. In the reverse way, he's giving a shawl to Professor Rao, and Mrs. Rao is there. And again here, his own photograph drawn by a famous artist, which is gifted to Professor Rao by Professor George. And again, Mrs. Rao is also given a gift here. So their friendship is a long-lasting friendship for about 55 years. This 55 years of enduring bond, and I would say this bond is stronger than an ionic bond, and celebrating 15 years of friendship. Look at this. Let me move to the next slide. This is a beautiful video. And before running this video, I would like to ask a question myself this morning. Why Professor Rao arranged JNC conference in the first 3 days of October 1, 2, 3. I have been associated with the JNC conference in the chemistry of materials for 16 years, along with Professor Kulkarni, Professor Chandrabas, Subi George, and Professor Ishiri Murthy. Always there is October 33 will be there. Why? What is the reason? And I guess this is the reason which will tell self-explanatory. Can I run this video? Okay. This October 3rd, he ensures that he's in Trivandrum. They celebrate the birthday together. The conference is arranged in such a way that now I understand the reason behind it. Then the most interesting thing, I know whether you heard that every afternoon, every lunch table, they took lunch together every day in IIT Kanpur. This was told to me by Professor George. And every day he used to tell you should get married, and he'll never got married. So that is what he was telling. I hope some of you might have heard that conversation. Let me go into this is sufficient to tell about the friendship of Professor Rao and Professor George and Madam Indumati Rao. Now let me move into the life of Professor M.V. George. Early life of M.G. George is already explained, but I will go very quickly. He was born in Ashtamudi. This is about 130 kilometers, 75 kilometers away from Trivandrum. It is a beautiful place, and his father is M.O. Verghese and mother is Sarama Verghese. He was born as a second of the 5 children to his parents on October 3, 1928. His father was owned passenger boats and also have some agriculture as the thing. And his early education was in a government school in Kollam, and he moved to Union Christian College, Alway, for the pre-degree. Now we call it as +2. Earlier it was known as intermediate. What's the delay here? Okay. Professor A.R. Anandaraman, a professor at Alway Union Christian College, impressed him a lot. Totally dedicated to teaching, caring for his students. He was a very articulate teacher, could convey his thoughts very clearly. His lectures were supplemented by demonstration. This again from the reminiscence of Professor M.V. George, his own document. I have taken these lines. I think he does having a far-reaching impact on him, because always he cared his student. He was an articulate teacher. I was told in IIT Kanpur his lectures were very organized. I will come to that in a little minute later. And Madras Christian College, he did his master's, and he was very unhappy with the performance. He told at that time India was getting freedom, 1947, and the things were not that great. So he was not happy at that time because he said that he was an average student, he says, and his own writings, I took this one. And then he moved to Agra, St. John's College for his MSc. There he had excellent teachers and he was motivated to pursue chemistry. And all throughout his career, Professor Anandaraman, his undergraduate teacher, was an inspiration for him. He used to write letters and ask him to pursue higher studies. I think something is happening. I don't know what is happening. Okay, so Agra University, he did his PhD. This PhD is on Perkin reactions and Novajonan reactions. It's a Perkin reaction mainly, and it is with a Professor Itivaria as the teacher. Can I remove this one? Something. What is happening?
Come on.
There's some interruptions. Sorry. Really sorry, Professor Rao. There is some interruption in here.
Okay.
They're having trouble there.
You're not probably seeing it. There is some interruption. A small interruption because some weird lines are coming up on the screen for no reason. We don't understand how. I'm not sure if somebody is interfering with the pointer. I'm told by somebody that they can mess with the presentations. They're technologically very advanced guys. I hope somebody is not connecting with the system here.
No.
Okay.
This is not the.
It can be done easily.
No, that's not the one.
Live with the simple ones. That's better. Should practice all this.
I will use this one. Okay, from Agra he moved to Professor Itivaria, his supervisor encouraged him to go for postdoc. For 2 years he worked in Agra St. John's College as a faculty member, and from Agra in 1956 he moved to University of Toronto. I think he has written nicely how he went. He went first to London and London to New York by ship and then to Toronto by train. And this is a long journey he went. And he writes about that journey very nicely in his memories. And in Toronto, he worked with George Wright, and he was working on natural products. and heterocyclic derivatives there, structural elucidation of Strawberry reactions and heterocyclics. And he published a paper in the Canadian Journal of Chemistry in 1958 from there, and he immediately moved to Henry Gilman's lab in Iowa State University, where we all may be familiar with the Gilman's reagent. And he worked with Gilman and again published a JACS paper in 1959. And then he moved to Ohio State University with Melvin Spencer Newman, where he's famous for Newman projection, famous for inventing the Newman projection. He worked with him, and there also he published a JACS paper. And then he moved to the Imperial College London with Barton, again a Nobel laureate, D.H.R. Barton, and where he worked more on the conformation analysis and related thing. And there is a publication from him. And then he moved to University of Munich, Germany, with Professor Huisgen for the 1,3 dipolar cycloaddition reactions. And when I was associated with him, I had done some 1,3 dipolar cycloaddition reactions with him between fullerenes and ylides. This is one of the, I have some memory, I worked on this project. So this is again a paper from his group, Professor George in chemistry with Professor Huisgen. And then he says that he gave a promise to his mother. He will come back to India. And 6 years, he never came back to home after going from Agra. He came back to India after 6 years. I had 5 postdocs, every postdoc 1 year only. And everywhere he published papers. That is very interesting. How organized he is, you can understand. And from there, No, it's not sharing. Professor Rao, you are seeing the slides?
Yes, we were seeing the slides.
You are seeing the slides?
Yes, we were. We can go back to the same mode, no problem.
Okay.
It's fine, George.
Yes. So then he moved to Bangalore, where in the department of organic chemistry department, he was a pool officer. And I was told that Professor George and Professor Rao both were at the same time in IISc. Professor Rao also was at IISc at that time. I don't know whether they know each other at that time. I don't know. This is something I had to ask Professor Rao when I met him next time. Then the trios. All the 3 were selected on the same time to IIT Kanpur in July session in 1963. Professor C.N.R. Rao, Professor P.T. Narasimhan, and Professor George. And these 3 people were responsible to make this institution, particularly the chemistry department, great. And you can see here the trials again with a professor from MIT. I was told it's a professor from MIT. They were discussing, and you can again, I'll go one step against about Professor George's words on, again taken from his diary. He says that Professor C.N.R. Rao, with his experience and enthusiasm, could initiate many features. That he wrote himself, I took it this morning from his diary. And he said that we have full freedom to plan and design academic curriculum. Courses were ourselves designed, full freedom in organizing a course, evaluate students, attend lectures, evaluate the students' coursework, essentially managed internally. So he writes about his days in Kanpur, and most interesting thing, it is connected to Ram Ramaswamy's one statement: mother of chemistry department of IIT Kanpur is the mother of all chemistry department. There is an article in internet. Those who want can read that article, and there is an article in internet. I can give you the link if anybody is interested. And I am telling that these 3 people, Professor Rao, Professor George, and Professor Narasimhan, are responsible to make this is height. Then Professor George, again I will move to the Professor George. In IIT Kanpur, 63 to 88, he taught several courses, mostly organic chemistry courses, and he was meticulous teacher. He demonstrated exceptional attention to the details, time management, and this is a lesson for the young faculty members who are joining and starting their career. And he was so meticulous in his teaching, and I was told that he used to rehearse this one the previous day for the 1 hour, and then only he goes to the class every day, which even the lectures are again repeated. And his research in IIT Kanpur as in 4 areas: organic phototransformation, organometallic chemistry, then the synthesis of heterocyclics, and mechanistic investigation along with the photochemistry. He has graduated 25 PhD students and 20 postdoc, and Professor Ila and all are and Vijay Kumar, Professor Vijay Kumar, many of them are there. I don't want to tell all the names. Gobidas, Dr. Ramaya, many of them are there, my own close friends. These students and postdocs are occupying important positions across the world. And this is something we have taken from his lab notebook. When he started, it's an independent researcher, he's writing it. I like this. Look, laser flash photolysis MVG 103 in the presence of phenanthrene. Phenanthrene solution was the one prepared in January 29, 1979. See page 233. Okay, 2 p.m. on this date. An entire lab notebook is like this. I think I had learned a lot of things from these things, and these are all lessons, and the way he writes structures in his lab notebook. So he used to go to lab to do research, do collaborative research in other places, particularly Notre Dame, and this is a lab notebook when he was doing some experiments, laser flash photolysis experiments in Notre Dame, and this is taken from there. So again, see that how meticulous he is. So these are the people who should be the model for the younger generation of our country, who can take some things from them and go forward. So now my interaction with Professor George and Professor Rao, and then I will go to the talk which I have been asked to do. So my interaction with Professor George goes into 1987. 1987, I had decided to move into photochemistry, but I need to have somebody to take me. And I have gone across many places. I think okay. Many labs. So finally, I went to IIT Kanpur and met him. He said, you can join your lab. One condition. You have to, 1 year, I will watch you. You have to perform. Otherwise, I'll kick you out. So that was it. So the interaction with him was 10 o'clock in the night. And I was asked to go and meet Pradhaban, who is a student, and discuss. He will interview me, and Dr. Pradhaban will tell him whether I should join or not. Finally, he said, you can join me in my group. But then he wrote to me that in IIT Kanpur, I am moving out, I'm going to US, and then I will be back in Trivandrum. I'm going to join the NIST, then RRL Trivandrum, as an emeritus scientist, where I'm going to set up a photochemistry research unit. That is the first interaction with them. When I went and met him in his office, he took a paper and showed me. This is a letter from the Chief Minister of Kerala, then Chief Minister of Kerala, to join as the Vice Chancellor of Cochin University. He said, earlier I had similar one from Kerala University also, but I don't want to take administrative responsibility, because you know that before 60, if you become a Vice Chancellor, you can continue till 65 as a Vice Chancellor. But I said that, look, I want to build I want to build a group in Kerala in the area of photosciences, and that is my motive. So I am not joining, but you can join in 89 in my group. So the birth of the photochemistry research unit at CSIR NIST, then RRL Trivandrum, is like that. 89, he started this group, and this we can see here, Dr. Das, Ramaya, Dr. Ramaya, Dr. Ajay Ghosh, Govidas, and myself, all of them were together in this group, and all of them did their own way extremely well in their own way. And this is the birth of this group, and it helped a lot. But Professor George was always worried. He was too worried about a higher education scenario in Kerala. At that time, there are no centrally funded education institutions in Kerala. And he always tells me, this is why the people of this place are not interested in higher education. And we need to have, if you look at IISc Bangalore around is interested, IIT Madras it is interested, Hyderabad Central University is interested. What is here? Only state universities, and they also have their own difficulties, financial difficulties, and so on. So he said that we need to have a central institution. And he believed in it, and he used to go to every politician. He don't have any political affiliation, but he goes. Whoever is in power, he will go with a piece of paper with a recommendation. Can we go for this one? This happened for the first 10 years, 90 to 2000, and then only something positive things happened of Professor the IISERs, the whole idea of IISERs came, and Professor Rao's intervention, and that is already told by Professor Murthy. The absence of a national education institution in Kerala during this period, he was really worrying him. And then he started parallelly certain things. The foundation of capacity building in science, along with Professor Rao and Madam Indumati Rao. We have 19 workshops for college teachers. The first thing he did is call the college teachers, postgraduate teachers and students, and have 3-day workshop, expose them to newer areas of chemistry. And this is something he does every year. And this, he having a foundation supported by JNC and few other places, and his own ways. Then he has lectures in the schools and various colleges, distinguished lectures. And more importantly, I was associated with this JNC conference on chemistry of materials directly with Professor Rao. So these are some writings. I thought I will show you. This, he used to go to every place, and everything is written in his diary. This is a thing. Meeting, this is very relevant to IISER Thiruvananthapuram, so I kept it. Meeting with Mr. P.J. Thomas, Additional Chief Secretary. Suresh Das, George Thomas, and myself met. P.J. Thomas is in office. Secretariat Annexure, 3:30 p.m. on Wednesday, March 7, 2007. We discussed the choice of land at IISER and decided to go to Vidira on 13 to see the place. 300 acres of land was required. Nowhere Kerala 200 acres of land is available. And central government said, we are going to change the IISER from Kerala to another state. It has to be in south only. And Professor George was worried. And then Vidira visit. George Thomas and Suresh Das collected me on Tuesday morning, 7:30 from my sister's house. Later went near Women's College to collect P.J. Thomas, who is the chief secretary. Both myself and he went in his office car, whereas Dr. Dasan came in George Thomas's car, reached Vidira at 9 a.m. and spent things. And this goes on. And then the land has to be transferred permanently. And he worked for that. And he worked for that. It was not easy to completely transfer the land to the central government. Usually it is given on lease, but he worked. So he used to go to secretariat with his paper, sit there, see the chief minister in the order or the education minister for this cause. So this is, again, I'm telling his interest in setting up this IISER in Trivandrum together with Professor Rao and others. His workshops, Dr. Joshi helped me in arranging the organized way. 19 workshops he arranged for FCBS workshop, supported by JNCSR, 2002 to 2015. And one was online, if I remember correctly. And you can see some photographs. A lot of students sitting here, college students and school students sitting here. These are college students, school students sitting here. This has motivated us as a spirit of science came to Kerala because of this one. I can see the transformation. Since I was here, I can see this transformation. The spirit came, how it came. These are the FCBS lectures in colleges. You can see how many FCBS lectures are conducted in various colleges by Professor George in support of Professor Rao. This is a photograph from JNC conference on the chemistry of materials. You can see Chandrabas here, Professor Ajay Sood here, and Professor Rao here, discussing something on chemistry of materials. You can see here. This was conducted in Kollam, Cochin, Alleppey, Munnar, and Thiruvananthapuram. 16 conferences on the chemistry of materials have happened. My association with Professor George I have mentioned. So the turning point of my life, I said, workshop on study of fast chemical processes was in Lonavala. I decided to move to another area, and I shared the room with Shamalalava, who is sitting here. We were together in this period. Both were students. We sat together. We were in the room, and I decided to move to photochemistry, and that is how I joined Professor George's group. Now, my reflections on Professor George. My reflection on Professor George, I want to have, what is Professor George? He is altruistic. What is altruism? It's a character of trait which describes an individual who is selfless, compassionate, and motivated by a desire to help others without expecting anything in return. And actually, Professor George was this one. And I believe Professor George was an altruistic individual. This is my own reflections on Professor George. my reflections with Professor Rao is also very interesting. In 1989, I joined. 1994, I was elevated as a scientist. I joined as a scientist in this group. And 1994, I was the one nominated from NIST for the CSI Rank Scientist Award. I went to Delhi for the CSI Rank Scientist Award, and Professor Rao was chairing the meeting. And I didn't get that one. That time we cannot travel by flight. I can travel by train only. So in the train, I thought, why I am not getting, what is the problem? I was thinking. Next year also, I was eligible. I was selected, nominated. I went to Bangalore. This time also, Professor Rao was the chair of the committee. I was not selected. But after that meeting, after that, Professor Rao came to me. He has a fruit bowl, still I remember, bowl on his hand. And he said, George Thomas, you have to do something different from others. And I had decided, I'm going to do it. Do or die, I will do it. So this is the turning point. I would tell you, this is the turning point where I decided to do something different. So you cannot do similar things what your colleagues are doing. It should be different. And then only you will be noted in the country. And if you want to become noted in the country, you try to be different. And this is advice I got from Professor Rao, and I followed that advice. And then I started working in a project. Interestingly, in 2001, I have in the Indo-Japan exchange program. I was in Japan in Hokkaido. At the time, I get a letter from Professor Rao. I have read your recent paper on gold nanorods, and you are invited to give a talk in IUPAC meeting. The same Professor Rao, I still kept that letter, that first invitation to an international conference. So let me go into the why. I took the advice, and many times his advice is not a great thing today's, but still I followed my advice. I am a beneficiary of advice, and I hope my young colleagues will understand the importance of an advice of a person whom you believe that will support you. Again, so exploring the light matter interactions and nanoscale is the topic, where the incident light falls into a molecule or a material. It fluoresces, transmit light, or scatter it. So our group look all these three things, and I will quickly go through some of the thing. As Professor Rao said, I had to be different, and how will I be different? I know these molecules have a transition dipole, and together with Dr. Das, in chromophoric dyes, we were doing a lot of things in H aggregates and J aggregates. So the two transition dipoles, when they couple each other, a new spectroscopic signal is emerged. So this is the thing how it's two monomers, they couple together to have a higher energy state and two lower energy state, and this will give a new spectroscopic signal. But if it can be linear, it can be parallel, and it can be oblique. And if it is oblique, it can be in two ways. It is a left-handed one and right-handed one. And this can give chirality. This is something known in the literature. And this is known in the molecules. Let me think something different with the materials. So I moved into materials. And we have summarized later a review article together with Swati on molecules and materials. What are the parallels on the excitone coupling? And again with Anna Pailani and Christina Sisa on chirality. Two reviews were written, and those who are interested can go into these reviews and read that one. So what is here what we are trying to do? Molecules have a transition dipole. And you can see these transition dipoles, they couple each other to form new spectroscopic signal. Similarly, materials, if you look at plasmonic materials, they also have transition dipoles. And this was not looked at properly. And if you can bring them close by, they can couple each other and they can talk each other, and new spectroscopic signal can be seen. So this is something we were interested. So as an independent researcher, I started working on it. This is the gold nanorod. We having two longitudinal and transverse band, and sphere has only one band, and these are all known today in the literature. At that time, it was not there. I have a wonderful student, Binil. He is in US now, in Boeing. He was heading one division in Boeing. He came up with an idea. How will you link two things? So we came up with an idea that mercaptopropionic acid. So the gold rods are known to bind with thiols. and you have the carboxylic acid, it can undergo hydrogen bonding. So I have this flavor of organic chemistry and also a little bit of inorganic chemistry. So this helped me in thinking of a structure like this. And this paper was the first paper. It is cited heavily, but this paper even long because this paper was beyond much earlier of time. And we sent this paper to Nature Material, JAX, everywhere rejected. But the paper was sent to JFISCOM the same day it got accepted. Mustafa El Sayed, who was the editor, who could understand this one. And again, I want to tell this paper, actually, there was no way to get a TM. So I had to collaborate with Prashant Kamath to get the TM of this one. And this paper was one, but followed by that one, we have done the electrostatic interaction, which got published in JSCS, but this is cited about 700 times now. And followed by that, we have done the covalent interactions. So this has become an important area of research in our place. So this was a breaking the glass ceiling. It took a long time to. So this is also an young generation I want to tell. Sometimes the first paper, it is very difficult to establish and convince the world that this is possible because we were far ahead of time. And then you can see the parallels. This was something I was doing with Dr. Das, where the aggregates are formed, very similar. When they couple each other, you see a new band is formed. Here also a new band is formed. There are parallels. I could understand, I could appreciate these parallels between the organic material and the inorganic systems or plasmonic systems. Then actually, Dr. Swati joined our institution, and I was Dr. Swati and myself, we worked together on a project where the plasmonic field, to measure the plasmonic field. So we have a silica coated with a gold nanoparticle coated with silica of different shell thickness, and we bind it with a pyrene molecule, and pyrene will be on the silica shell, and it will be experiencing different intensities of electric field. And we want to map this interface, and we did that one, and we could find how the field decays and how this Raman signal intensity enhanced. This was a very important paper from our group, I believe, because the field we could calculate experimentally. But this has led to another interesting thing. We know that after 6 nanometer, the electric field is not there, because when the electron cloud on the surface of metal particle, when they oscillate, there is a field created, and that is not there after 6 nanometer. So then we come up with an idea where you can have a sieving and a silica with pores, so that large molecules will be all filtered, and the small molecules will go inside and experience the field. And this work was again published as an applied work with Hemna Fatima, who was one of my students. We call it as sieving and sensing, and we have shown that when there is pesticides in a tomato matrix, we can directly detect that one. So this is again moved into the electric field. The electric field at the junctions, the spectroscopy at the junctions, you could see the Raman signal. So when they couple each other, there's a field generated, and that field, again, when the molecule is sitting in the field, and the Raman signal intensity enhances. And this is the work carried by Jatish, and this led to the hotspot, the understanding the hotspot. And again, this is a work together with Dr. Swati, in collaboration with Swati. We have a linear correlation between the field and the distance. And we could say that at what distance we can bring them. These are silica. Between the silica, you created these particles, and we could see the Raman signal intensity, how it increases. The coupling we could see in the electronic spectrum. We could see the coupling, and the Raman we could see the signal. And this led again to a real application. In the gold, we coated this in a capillary tube, and this capillary tube was used for sensing application. Even TNT, pyrene, and even bovine serum, albumin, and all are detected using this one. And this was published again in a journal of ACS Applied Materials. Finally, we could translate it into a benchtop device. I have support from collaborations from Dr. Anil Shahji, Dr. Sheetal, Dr. Arun, Dr. Swati, and Aditya in this project. This is done together with them, and Chandrabas Narayana helped us in setting up a benchtop Raman spectrometer. So this is the work on plasmonic, the first part of the plasmonic. The plasmonic work which we continued, and we looked at the plasmonically powered systems. More recently, we are looking at, instead of SCRS, can we have the emission enhancement? And this is again an important area, because in emission, if many molecules have low emission, we can enhance the emission. This is something we are looking at. Another work which we did again in collaboration with Dr. Swati, this work is initiated by Anup and Reshmi and followed by Ajay Kumar. Their plasmon exciton coupling. Plasmons, a plasmon again is a transition dipole. And again, a molecule also has a transition dipole. When they have same energy, more or less same energy, they couple each other, they talk each other, the distances are correct, and two states are formed. And then you can find whether it is a strong coupling or a weak coupling by various methods. And this is something we are doing. The first paper of this was Nacius Nano, followed by this one in this one. And this is the latest paper in this direction. We did the whole thing in single molecule. Single molecule, again, in the change in refractive index, and again, change in the polarization. You can see the splitting of the two bands because the two states are formed here. State here and states here, there are two bands formed. It decays and increases because we do the polarization dependent study, and this work is done by Ajay Kumar, currently with my group. So again, this is related to the transverse and the longitudinal coupling with the dimolecule. The most exciting work came again for us is can we bend it? Can we tilt it? Can we rotate it? So what we thought, how the seashells are generated, how seashells are formed. So you take a template, you have the marine organism, and the marine organisms, there are amino acids, and these amino acids, the calcium will go and deposit it, and they grow on the surface. That is how the seashells are formed. It is left-handed, it is right-handed. Can we adopt this and create a chiral plasmonic material? So this paper was again much ahead of time. We called it as the chiral organization of an achiral plasmonic structure and the resonant plasmon coupling leading to bisignated CD signal. This was published. This paper is well cited, published in JICS. We used peptide nanotube instead of a marine organism surface, and we could see the bisignation, a positive couplet and a negative couplet we could see. But later, the new term came called chiral plasmons. Today, if you look at a lot of papers are on chiral plasmon, this paper is not cited as much as, even though this is the first paper to demonstrate that the new term, that on the surface of a chiral template, you can organize them and create these chiral structures, which is showing the bisignation. Unfortunately, because of the new terminology brought in the literature, our Western world has brought a new terminology, and our papers are not that much cited as it should have been. Then we followed our work in plasmonic chirality, where we took a template, and on the surface we grew the metal particle helically and removed that one, and you can get this plasmonic material, left-handed and right-handed. We made semiconductor chirality. Recently we did it, and we also made organic molecules chirality. And these are some of the work which we are currently pursuing in the lab. More recently, with Balasubramaniam in JNCSR, we have looked at amino acid. We made amino acid templates. These are cryo-EMs of amino acid templates, long templates we create. And on the surface of that one, we have these molecules, organic molecules. These amino acids are not chiral, and you can see that when they bind, these molecules bind. These are achiral molecules. When they bind onto the surface, it is getting tilted. And as a result of that one, new chiral features emerge. This is again how the chirality is emerging in the universe, is translated in the universe. We know this is again the two papers we have published recently in 23 and 24. Again, you can see the exciton coupled chirality here and high CPL from these systems. Here essentially the molecule undergoes a twist and a J type of interaction on the H type of interaction. Here there is an H type of interaction, H type of a coupling form, and it's a J type of coupling forms. And this is again a very interesting exploration in the last 2 years with our group and Professor Balasubramanian's group in JNCSR. Now, let me move into the semiconductor photophysics, which we are doing. The photophysics of semiconductor quantum dot is also another area of interest, just like the plasmonics. Here, this is a work carried out by Anup Thomas, who is in IISc now. We have two types of quantum dots, a quantum dot of cadmium selenide and indium phosphide. Cadmium selenides are 2,6 semiconductor. They are ionic in nature, and you have indium phosphide. These are covalent in nature. So their characteristics are totally different. And we have shown that these have deep trap state and this has shallow trap state. And as a result of that, these are long-lived. The electron transfer products are long-lived. It goes to milliseconds. And this paper was published through a hopping mechanism. We have shown that it can go even to seconds. The electron transfer product stays for seconds. That is what we are saying. So this is a recent work carried out by Devika in my group, along with Aditya. Aditya did the 2-photon studies where we had tagged M-cherry into indium phosphide, and we could see the energy transfer and 1-photon and 2-photon energy transfer. So these are the work on this the steady state experiments in the ultra-fast time scale. We do this one, but we moved recently into single molecule spectroscopy. In the single molecule spectroscopy of these systems, we are interested. These are time-resolved single molecule spectroscopy, and one of the a review recently we written, a perspective recently we written. In ensemble, we look at the bulk property. Here you are looking at the single molecule. This is the wavelength. You see the spectrum. Here your spectrum is broadened. Here this is narrow. Because this broadening is because it's an ensemble effect. Here you can again see the time. In a time, if you look at it, in a time course, as a function of time, some molecules will be in the ground state, some molecules in the electronically excited state. On a steady state, you will not see any change in the intensity, but you can see these fluctuations in the single particle. And this fluctuation has a lot of information. And this information is what we are studying in the single molecule spectroscopy, where the one interest what we have is that make semiconductor quantum dots which can emit single photon or emit 2 photons. This is something we are doing. So here, if a bunch of photons are coming, if you have a 2-detector system, it's a beam splitter, it goes to 2 detectors. As a result of that one, a central peak is formed. But if there is only 1 photon emitted at a time, then it will go only to 1 detector and there won't be any central peak. I'm not going to the details behind this and why it is happening. It is more elaborate in nature. But here you can get a time, this timed intensity, both information will get. You have the intensity information, you have the lifetime information, and you can plot the lifetime intensity plot. And this scatter plot can be converted into a density plot. And from the density plot, you will have a lot of information about the molecule. So what we are trying, what we are looking at the dynamics at a single molecule. First of all, we have to understand if it is a single molecule, the electron is transferred to a trap state. There are sometimes it's a deep trap state, sometimes it's a shallow trap state, and it can detrap if the trap states are shallow in nature. So all these dynamics at a single particle or a single molecule level, we are investigating. One example recently with the first system that we studied, this paper is highly cited paper. This quantum efficiency increases from 2.9. When we increase the size from 2.9, the quantum dot to 4.4, which is close to Bohr exciton radius. The reason is why. It is not in the literature why there is a reason. And we did a lot of studies on this one. And we found that these are the intensity time trace. If you do this in the ensemble level, you will only get a straight line. You can see the fluctuations. And these fluctuations, on and off states, it will have a lot of information in it. We can extract the information from that one. You can see this is off form is more, here on form is more, occurrence is more. And you can see the lifetime increases when the on form is there. And we did a lot of analysis. And we have concluded that there are 2 processes. And one is in this case, when the size is large, there is only one process, that is the direct exciton recombination. Here there are 2 processes, and you can see another process happening. Here this process is more and the direct exciton recombination, which we want. We want a system to be bright. And that is again something called an Auger recombination. We could get the kinetics of the entire process. I don't want to do the technical part of it, but this type of system is essentially useful for display applications and various applications that we are investigating. So this is one aspect of we are looking at it. Larger quantum dots are better emitters than smaller quantum dots. This is something we investigated. Another thing is that the exciton delocalization we studied. Again, we do the anti-bunching too. We call it as anti-bunching studies to see that the central peak is not there. Then we can say that there is it is a single system, and you can see the on form. This is the on and this is the off thing. Here we have a lot of information about the decay, lifetimes. And from this lifetime, we can calculate the delocalization, and we could see the delocalization of these systems. This is also recently published. More recent work is on the exciton by exciton. Yeah, exciton by, how much time I have? Yeah, exciton by exciton system. We are calculating. I'm just going deep into that. Here also the final thing. There are sometimes one photon, sometimes two photon. How will you separate it? And we do something called photon anti-bunching bunching studies and time gated, because the first photon will come very fast and the second photon will be slow. And we do a time gating study, and we have found that the time gating studies is useful to understand or characterize the single photon material with a two photon material. And we have shown this one with the perovskite material, which is cubed to 16 faceted to 26 faceted. So I have just, these are some of the things. We can again calculate the biexciton yield and the OJ processes. These are some technical part. I'm not going to the technical part of it. We can also look at the exciton by exciton delocalization we study. These systems are made by Narayan Pradhan's group. We can select it. And finally, these are the two aspects we are working. So we are working on chirality, we are working on semiconductor quantum dots, we are working on plasmonics. We have another area of interest, which is the STM, which we stopped for certain reason. We did a lot of work on STM. A student of mine, Yusuf, did a lot of work, and followed by few other people. I had collaborations with Prashant Kamath, Dr. Swati, Dr. Anna Paileni, Stephen Gray, Shobana Narasimhan, Balasubramaniam, the Narayan from Cultivation of Science, and Christina. And these are my strong collaborators. And recently I have started a collaboration with a French group also, which I have not mentioned. We have not published any paper. Dr. Robert Philippe, Joshi, Subi, and Pramod Pillai helped me a lot in getting many photographs organized. And I support from the family I had to mention in this talk, because get up at 4:30 and writing paper is not great for people who want to sleep a little bit late. So I thank them for that. So I have accommodating me in my style of working. These are my students. First student is Biju, Sina, Binil is in Boeing, Sandeep, James, Shibu, Yusuf is in Kochi University, is a professor there. Pramod is a professor in IISER Pune. Vinayagan is in college. Ramesh, Gino is in IISER Mohalli. Pratish is in Mahatma Gandhi University. Is in Tirupati IISER. Shandil is in college. Anub is in IIC Bangalore, IPC. Subila is in MG University. Pratap is in Maharashtra. Reshmi is a development editor. Sapnam is in IIT Bombay as a postdoc. Sandeep is in a government college doing extremely well. Hemna is a publishing editor in RSC. These are all postdoctoral fellows in various places. Modit. And this is my group. This is my group. And last day, I think Vishnu went for a postdoc to Germany, and Vishnu is the one who did all the single molecule, standardized single molecule chirality. Recent work is done by Sanup, and Sujit did all the chirality recent work. Ajay Kumar did the single particle scattering work, recent work. And finally, thank you, Professor George, even though he's not there, thank you for all what he has done, and Professor Rao for the great support he has given me over the years, and Madam Indumati Rao. And also I thank the Institute for organizing this. Professor Jayan Murthy, as he said, we are quite long friends, work together, and Dr. Ajay Venugopal, who is the head of the department, for organizing this event. Thank you so much.
Thank you, Professor George Thomas. 20 years of your research work, and also highlighting your association with Professor Ram and Professor M.D. George. I now request Director Professor Jayan Murthy to come to the dais and felicitate Professor George Thomas with the Professor M.D. George Endowment Prize. With this, we come to the end of the endowment lecture. We are extremely grateful to Professor Bharata Ratna Professor C.N.R. Rao and Srimati Indumati Rao for being with us online. And also I thank all the senior professors and colleagues all over the country who joined online for past 1 hour, faculty members and students at IISER Thiruvananthapuram. Yeah, thank you very much, and we conclude.